Hello, Charger family. This is Mrs. Boyd, Mrs. Boyd's Math Room. Today, thanks for joining me for proving lines parallel. It's going to be amazing. So when we do these proofs, they're in two columns. Hence why we have the if column and the then column. The things that are listed here are the things that you would list in the if column. The then are the reasons you might use. Really, when we're doing a proof, like on Alex, it'll be, this will be your reason. You'll be able to say, angle A and angle B are congruent because corresponding angles are congruent. This will be your reason. So we have these 1, 2, 3, 4, 5 different statements, and they all mean the same thing. So if corresponding angles are congruent, if alternate interior angles are congruent, if alternate exterior angles are congruent, if consecutive interior angles are supplementary, and if two lines are perpendicular to the same line, then the lines are parallel. It's just that easy. If we can prove that any of these 5 things that we already know to be true are true, then the lines have to be parallel. It's kind of the reverse of what we've been doing so far. Let's put this into action. If angle 1 is congruent to angle 5, angle 1 is congruent to angle 5, then that tells us that the two lines A and B are parallel. That's the sign for parallel. Two parallel lines like railroad tracks, because it's the converse of the corresponding angles postulate. Corresponding angles postulate, if you'll remember, tells us that if two corresponding angles are congruent, if two lines are parallel, sorry, I'm backwards. If two lines are parallel, then corresponding angles are congruent. We have angle 4 and angle 6. These angles are alternate exterior angles. Line C is our transversal, and A and B are the lines that cross through that transversal. It makes 4 and 6 alternate exterior angles. If angle 4 and angle 6 are congruent, then A is parallel to B, because the converse of the exterior angles theorem. Exterior angles theorem tells us that if two lines are parallel, then the alternate exterior angles are congruent. And I forgot the word alternate, so let me just erase this real quick. And it's the alternate exterior angles postulate. Next one, angle 2 and angle 8 are congruent. Angle 2 and angle 8 are alternate interior angles. So if they are congruent, line A and line B are parallel, because it's the converse of the alternate interior angles theorem. You know what? I really screwed this one up. This should have been a theorem. Ignore that. That's a theorem. Holy cow. Can't take me anywhere. Next, measure of angle 2. So angle 2 is here, plus the measure of angle 5 is 180. Well, there's going to be no surprise that line A and B are going to be parallel, because those are consecutive interior angles. So this is the converse of the consecutive interior angles theorem. These are all theorems, but one postulate. I messed that up. I'm so sorry. All right, now we have angle 2 and angle 4. Those are vertical angles, you might notice, on opposite sides of the x. 1 and 3 are also vertical angles. Unfortunately, vertical angles at this point tell us nothing about the two lines or how they're parallel, because we only care, that only uses two sets of lines. They can't be parallel. All right, let's look at one more possibility. A is perpendicular to C and B is perpendicular to C. So it doesn't look like it in this picture, but if we have A is perpendicular to C, then this is a right angle. If B is perpendicular to C, then this is also a right angle. So that would tell us that A is parallel to B, and it's again the converse of the perpendicular transversal theorem. That if two lines are parallel, then their transversals are perpendicular. Let's flip your paper over and we're going to put what we've learned here into work on some proofs. So we're given angle 3 and angle 8 are supplementary. Well, that's always going to be our first statement. Angle 3 and angle 8 are supplementary. Oh, cat's up here. The reason given. We want to prove that A is parallel to B. And we can say, without a shadow of a doubt, that line A is parallel to line B because converse. Let's look at what these angles are first. I forgot about that part. We have angle 3 and angle 8. These are consecutive interior angles. So this is the converse of the consecutive interior angles theorem. So that was a two-step proof. Those are my favorite. Quick and to the point. Next one. We're given angle 1 is congruent to angle 2. So let's write these down. Angle 1 is congruent to angle 2. And angle 1 is congruent to angle 4. That's given. Let's look at those angles. Angle 1 is congruent to angle 2. And angle 1 is congruent to angle 4. Well, we know that if angle 1 is congruent to angle 2 and 1 is congruent to 4, then 2 and 4 have to also be congruent to each other. So we can say here that angle 2 is congruent to angle 4 because it's called the transitive property. Of congruence. It pretty much says what we just said. If angle 1 is congruent to angle 2 and angle 1 is congruent to angle 4, then 1, 2, and 4 are the same. So we can say that angle 2 is congruent to angle 4. So now we can say segment DE is parallel to segment GF because converse, to mention one more time what angles these are, 2 and 4 are alternate interior angles. So it's the converse of the alternate interior angle theorem. Last one. We want to prove, or we were given angle DEG and angle GEF are complementary, and DE is perpendicular to segment DG. And those are both given. Let's look at what that means in our figure. DEG and GEF are complementary. That means DEF is 90 degrees, which we're going to say in our next statement. Measure of DE looks like a P. Oh, Lordy. DEG plus the measure of angle GEF is 90. That's the definition of complementary angles. Now, the next one that we have, the next statement that we were given, DE is perpendicular to DG. We don't need that quite yet, but we do want to know, well, I guess we do need that right now, so sorry. EDG, if this line is perpendicular to this one, that means that this angle is also a right angle. So we know the measure of angle EDG is equal to 90. And that's the definition of perpendicular lines. So now we can prove that segment DG is parallel to segment EF because we know DGE or GDE and DEF are supplementary. We add those together and we get 180 degrees. So this is the converse of the consecutive interior angles theorem. Those two angles are consecutive and interior, and that is assuming that DG and EF are parallel lines and GE is the transversal. So this is putting all the things that we know about how angles are related together and forcing you to parse it out step by step to get from the beginning to the end. I hope this makes sense to you. If not, I hope you reach out soon so we can get you straightened out, and I hope to see you soon.